Okay, so converting between fractions and decimals. Right? Method 1, just memorize. Okay, memorize the 5 most popular ones. 5, okay, just 5, okay, which is 1/10, 1/5, 1/2, 1/4, and 1/3. These 5, okay. Let's look at 1/10 first. When you divide 1 is from here to there into 10 equal pieces, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, we call it 1/10. Okay, and then when we are expressing it as decimal, we decided to call it 0 and point and 1. This is the starting point. Okay, here it is. That's the first one. Okay, don't argue with it. This is a rule. Okay, and then when you have 2 bits of those, 2 parts of 1/10, right? 1, 2. That's of course 2/10, which is 0.2. But you will notice it is actually the same as 1/5. Why? Because if you take 2 bits of 1/10, it's the same as dividing 1 into 5 equal pieces. Okay, so which is the same as 1/5. Or when we learned equivalent fraction, we learned that if you divide both the numerator and denominator by the same number, top and bottom by the same number, you get an equivalent fraction. Right? So 1/5 is 2/10, which is 0.2. Okay, so that's the second one, right? And when you have like 3 parts of 1/10, that's 0.3. 4 1/10, 4/10 is 0.4. 5/10 is 0.5. 5/10 is 0.5. And you notice 5/10 is taking 5 parts out of 10 parts, is taking a half of it, right? Or you can think of it as 5 divided by 10 is, you can divide both by 5, top and bottom by 5, and you get 1/2, right? So 1/2 is 0.5, right? So that's the third one. And what do you get when you divide 1/2 by 2? Like, what is 1/2 of 1/2? 1/2 of 1/2. You know, you can use multiplication when you are saying of. 1/2 of 1/2 is 1/4. You know, multiply top by top, and then you get top. Multiply bottom by bottom, you get the bottom. Right? And or you can visualize it like you have a pie, you divide it into 2 parts, each part is 1/2, and then you further divide it into 2, then each part will represent 1/4 because you have 1, 2, 3, 4 parts. That's 1/4. And since 1/2 is 0.5, half of 0.5 is 0.25. Okay, that's why 1/4 is 0.25. And the last one is a little bit sneaky, 1/3. 1/3 is a bit more than 3. It goes a bit more than 0.3, which is 0.3333333, going on forever, infinitely. Okay, so we can write it as 0.3 with a small bar on top of 3. This means this digit will repeat forever. Right, so that's the 5 fractions, the most popular fractions you will encounter in your life, and then please just memorize those. I just explained why they are, but just like times table, it will be very handy, very convenient if you could just memorize them. For example, if you have like 4/3, okay, 4/3 is 3 times 4, 1/4, 1/4, right? So 0.25 times 3 is 0.75, or 2/3. 2/3 is twice as much as 1/3, which is 0.6666 going forever, which we can write it like this. Or if you have something like, for example, 0.6, then you know that's 3 times 0.2, so you know that's 3/5. Or if you have something like 4/3, which is 1 and 1/3, which is 1 and 0.33333. So we know that's like 1.33333, which we can also write it like that. Okay, that's it. Okay, method 2, conventional method. Okay, for fraction to decimal, right? Just do the division, right? And for decimal to fraction, I forgot to write it. Okay, put it on top of 10 or 100 or 1,000 or to the powers of 10. I'll explain how to do that in a minute. Okay, so first of all, from fractions to decimals. Okay, for example, 1/4, we already know by memorizing that this is 0.25, but how would you get it by the conventional division method? Okay, 1/4 is the same as 1 divided by 4. Okay, 1/4 is the quotient you get by dividing 1 by 4, right? So you just do the division. 1 divided by 4, you can put it in your calculator. Okay, how many 4's go into 1? That's 0, 0. Okay, and then you get 10 there. And how many 4's go into 10? That's 2. 2 times 4 is 8. 10 minus 8 is 2. And then you bring down the 0 there. And then how many 4's go into 20? 5 probably. 4 times 5 is 20. And you get no remainder. So you know 1/4 is 0.25. Right? Same thing with 1/3. Right? 1/3 is 1 divided by 3. So how many 3's go into 1? That's 0. Okay. How many 3's go into 10? That's 3. 3 times 3 is 9. And you get 1 again. And then you bring up the 0. How many 10's go into 3? And that's 3 again. 9 and 1 and 10 and 9 and 1 and 10 and 9 and so you get 0.333333 going forever. That's why you get this, and that's how you write it. Okay, we can do it with any kind of fraction. For example, 5/8. 5 divided by 8 would be, okay, how many 8 goes into 5? That's 0. So, and then how many 8 goes into 50? That's, I think, 6. 6 times 8 is 48. And then you have 20 there. 8 times 2 is 16. You have 4 and make it 40. And 6 times 5 is 40. And then there's no remainder. So you know this is 0.625. Right? So that's how you do it. From decimal to fraction, here's the thing. You know 0.1 is 1/10, right? So 0.8 is 8/10. The rule here is you put this digit after the decimal point on top of a fraction, and then for the denominator, for the bottom one, okay, you either have 10, 100, 1,000, powers of 10, and the zeros, how many zeros you have would be the same as how many digits you have after the decimal point. Here you have 1 digit, so you put 1 0, which is 10. Here you have 2 digits, right? So you put, okay, 2 digits. What if it was 1.79? Okay, then that would be 1 plus 0.79, which is 100/100 plus 79/100. So it will be 117/100. Okay, that will be that. Okay, how about this one? Again, this has 2 digits here, so you should have 2 zeros, which is 100, and then 24 here. It looks like it can be simplified. No, both can be divided by 4. So the denominator becomes 25 and the numerator becomes 6. Okay, here's a very interesting case. This is an extension, so don't worry if you can't do it. I don't think any college student are expected to be able to do this, but yeah, you know this is 1/3, right? But how would you, if you didn't know that, how would you do that? 3, 3, 3, 3 forever over how many zeros? And how would you lead it to 1/3? Isn't it? This is something to think of, okay? For example, there is like something like 0.142857, 142,857, 142,857, repeating forever. There is this decimal like that, or we can write it like 142,857 with a long bar there. Okay, this is actually 1/7. Okay, very simple, isn't it? But how would you, okay, it's possible to do it from fraction to decimal, but how would you do it from decimal to fraction? Here, from fraction to decimal, you just do 1/7 and you will get this. You will probably get this. But what if it's the other way around? Something to think of. Yeah, spare time. That's all.